Hello friends, welcome to this video series. Today in this session we'll see concepts based on boats and stream. This is an extension of a session which we did on relative motion. So this is a special type of a relative motion wherein we look into theory first and then we'll solve some problems. So typically in cases related to boats and rivers, the boat has a speed of its own, which is known by the term that speed of boat in a still water. And then other factor which affect the motion of a boat in a river is the speed of the river, speed of the stream or the flow of a river, right? So we'll see how these factors actually affect the motion. And when we say the speed of boat in still water, what does this mean, and what is the speed of flow of river? Then one other thing, like when we say that a boat moves in a river, so there are certain terms which need to be clear before we move into the details. Say suppose this is a river and river is flowing from this direction, so this direction becomes downstream and this side becomes upstream, right? So if any object or any boat or any steamer is moving along with the flow of water, suppose water is flowing this side, then that motion is called downstream, moving towards downstream or moving downstream. And when a steamer moves against the flow of river, that is known as upstream. So that is very basic in nature. Now we'll try to understand step by step. We'll build up the cases here. What happens? So suppose case 1, when a stationary object is floating freely in a river. So what does this mean? Stationary object means this object, like say hat. When I drop a hat in a river or any stream of water, so hat will simply float, right? Free floating movement means that hat does not have a speed of its own, right? So suppose this is a river, and hereby at this point one hat has been dropped, right? And this is a river, and this point, let's this point be a, and this point be on ground, right? A is a point on ground, and this is a river flowing in the direction of this arrow, right? So this side is a downstream. So now what happens? And say suppose river is flowing at a rate of velocity of river, let's say is 5 meter per second. So after 1 second what will happen? The hat will flow along with water. So after 1 second, this point on the river, this point, say suppose a dash, a dash will move to here, let this be b dash. This is the new, this a dash will come here because the river is flowing at 5 meter per second. So after 1 second, this will be here, let this point on the ground be b, right? So now when we are looking at the position of hat with respect to ground, so in 1 second, that is in that is in 1 second, after 1 second, with respect to ground, the hat has covered a distance of 5 meter, right? So can we say with respect to ground, the velocity of hat is nothing but 5 meter over 1 second, that is 5 meter per second, which is same as the velocity of river. So when we say velocity of hat is same as velocity of river, which is 5 meter per second, so that velocity we are referring with respect to ground, right? This we are saying with respect to ground, that a person on a ground would observe this hat to be flowing moving at a rate of 5 meter per second. This might appear very intuitive. You may think, I mean, why am I telling this? But this is a very basic over which we will build upon and see what are the how does we apply relative motion in boats and rivers. Now, so this was case 1. Now suppose I will take our case 2 here. Case 2. When river is stationary, but the boat is moving at a moving at say VB, velocity of boat. So now what happens? This is river and this is ground here, right? And here is a boat. Here is at this point A dash, there is a boat, right? Here there was a hat. So here is a boat. Corresponding point on the ground here, just this point, let it be A. A is a point on ground. So we see that at point T is equal to 0, boat is here. Now water is not flowing. The river is stationary. I mean water is not moving, the stream is not moving, only the boat is moving at a velocity of Vb. That Vb is equal to 10 meter per second, right? So what will happen after 10 second? After 10 second, the person on the ground will see that since water is not moving, but this boat will cover 10 meter per second on water. So boat will reach here at a point B dash, which is corresponding to point B here on the ground. So on ground, the person will see that the boat has moved from point A to corresponding point A to corresponding point B, which is nothing but 10 meter in 1 second. So therefore, the velocity of boat with respect to ground, that is on ground, we can say that velocity of boat is nothing but 10 meter covered in 1 second. So that is 10 meter per second, right? This also is intuitive, nothing to. And when we say velocity of boat here, that is 10 meter per second. So this velocity of boat means boat is moving on water, right? Boat is moving on water. So it means that on water it is moving at a rate of 10 meter per second on water, right? So this means that on water boat is moving at a speed of 10 meter per second. So that means I mean if this is a river, so boat was at this point on the river. After 1 second it will be at this point, which is 10 meter far, right? That is the meaning of this velocity of boat. So now we have seen the meaning of what is the velocity of river, what is the velocity of boat, and now we will come to the final case, right? Now we will come to the final case. Let me draw the case here only. I, this I case 3, where boat and water both are moving. So see what initially in case 1, the river was moving, river was flowing, whereas the hat, the object in the river, that is hat, was not moving, right? So we saw that what would be the velocity of object hat with respect to ground. That is nothing but the velocity of river. Now in the second case we saw that the object, that is the boat here, is moving, but the river is not flowing. So in that case, what will be the effective velocity of boat with respect to ground? Now in the third case, we have been given that both boat and water, boat is an object in a water and water is flowing in a river. So how does this case pan out? So this is a river. So river is flowing in this direction at a speed of VR, and there is a boat here at this point in water. This point in water be given as point A dash, corresponding point on ground, from ground let it be A, right? corresponding point here, let be A on ground. This is a point on ground. Now what happens? After 1 second, this, what will happen now? This is a combination of case 1 and case 2. So after 1 second, this point on water independently would move by, let this VR be 5, and this is moving here VB by 10 meter per second, right? So what happened? Independently, this point A dash on this river will move by 5 meter in 1 second. So this will move 5 meter from here to here, it will come, right? And this velocity of boat, when I say velocity of boat is 10 meter per second, that is boat is moving on water. So with respect to water, this is moving at 10 meter per second, right? With respect to water. So that meaning if water was stationary, then it would have moved 10 meter per second. But here water has also moved by 5 meter. So from here it will be further 10 meter per second, right? Just combination of case 1 and case 2. So effectively, with in the frame of ground, we see that in the frame of ground is, we see that the boat has moved from point A on the ground to this location on ground, right? This corresponding location on ground, which is B. It be B dash here. Now see, again I repeat this. What happens? Then this VB is the velocity of boat is 10 meter per second, but that is with respect to water. When we say velocity of boat in still water is 10 meter per second, right? That is what is given here. So when we say velocity of boat is 10 meter per second in still water, means that is the velocity of the boat with respect to water, right? Now in 1 second, this point A dash will come to this point, say A double dash, right? In independently, this because of flowing water, that is 5 meter in 1 second. And this VB would move with respect to point A double dash, because with respect to this point, right, it will move 10 meter per second, meaning that the boat will catch hold of this point. Boat will not leave this point. With respect to this point, it will travel 10 meter per second, 10 meter. So basically, in 1 second, the the point on the river A dash reaches to the point A double dash, and with this respect, this point, the boat has moved further 10 meters. So this is 10 meter, right? So therefore, the total distance from A to B is nothing but 15 meter. A to B is 15 meter. So now if we see, we can say that what is the effective, so standing at a person standing at A will say that in 1 second, the boat has covered 15 meter in 1 second, right? So this is the velocity of boat, but with respect to what? Not with respect to water. This is with respect to ground, right? With respect to water, we know that it's only this 10 meter per second, 10 meter. With respect to water, the boat has only moved 10 meter. However, with respect to ground, so that is velocity of boat with respect to ground is nothing but 15 meter per second. So that is what is given here. So, and this is the effective speed. This is the effective speed of boat uh, with respect to ground. So that is what I have written here, summarizing it in 3 sentences. That in still water, the speed of water in the boat is, speed of boat in water is given as VB. That is nothing but velocity of boat relative to water, right? Now, while moving upstream, so let's first see point C. While moving downstream, that is along with the flow of water, the effective speed of the boat is now VA plus VR. VD is equal to VB plus VR, where VD is velocity downstream is equal to velocity of boat plus velocity of river. So, and that is what is here. This 15 is nothing but what? 5 plus 10, which is nothing but VR plus VB. And this is the effective velocity, which is velocity downstream. That is nothing but the velocity of boat with respect to ground. Similarly, had the boat be moving, so that the second case, that is while moving upstream, what will be the effective speed of boat? This we will see in the next slide. So let us see here. Here I again upstream movement, I will take a case. So here what happens, that there's a river flowing in this direction at a speed of VR. There is a boat here which is moving in this direction at a speed of velocity of boat which is say 10 meter per second, and this is 5 meter per second. And when I say this VV, that is with respect to the water, right? So effectively what happens, after 1 second what will happen, the point A dash here would have moved to another point A double dash here which is 5 meter, right? So this point A on the ground would have come to this point B. Okay, I mean independently this point would have come this. However, the boat has moved at 10 meter per second with respect to this point A dash. That is, from A double dash it would have moved 10 meter in left direction. So that means from here 10 meter, right? So this is basically nothing but this is point B. So that effective distance between A and B is nothing but 5 meters, 10 minus 5 meter. So basically what happens, in 1 second the boat has covered 5 meter in 1 second. So this becomes the velocity of boat with respect to ground, and that is the effective speed which is velocity of the boat upstream, and that becomes nothing but what, velocity of boat minus velocity of river. That is what we did. Velocity of boat is 10 minus 5 is equal to 5, and that is what we got here. So velocity of boat in upstream is velocity of boat in still water minus velocity of river. Similarly, velocity of boat downstream is nothing but velocity of boat in still water plus velocity of river. These two relations we should uh, remember. I mean, this is quite now clear enough. So if these two equations, if I add here, so here velocity upstream is equal to velocity of boat in still water minus velocity of river, and velocity downstream is equal to velocity of boat in still water plus velocity of river. When I add this, what will I get? I will get this as, this will cancel out. So I will get VU plus VD is equal to 2VV. From here I can say that velocity of boat in still water is nothing but VU plus VD by 2. And what is velocity of boat? This is nothing but the relative speed of the boat with respect to water that we have seen. So this is one relation. I mean, this will be helpful if we remember. Otherwise, also it's not a big thing. It's easily derivable. Now, another concept I'll quickly touch upon. I mean, what is it? Let us see here. Now, see, we see the relative speed concept with respect to boats and rivers. So now see what happens. I mean, earlier we had seen that when a, say suppose, car is moving at a speed of VC and a bike is moving at a speed of VB. So what is the relative speed of car with respect to boat? They are moving in the same direction, so that is nothing but VC minus VB, right? That we had seen in the previous session. So now a question might appear, I mean query or a confusion might be there, ki that if suppose if river is flowing in this direction at VR and a boat is also flowing in this direction at VB, so why are we saying that effective speed downstream is VB plus VR? This we need to understand. See, this is the velocity of car with respect to bike, right? Now see, and we know that when the two things move in the same direction, the relative speed is difference of the speed. But here when the boat and river are flowing in the same direction, we are effective to get the effective speed, we are adding. Why is it so? Try to understand here. See, here car is moving with respect to this, vc is nothing but vc with respect to ground, right? Velocity of car is this with respect to ground, and velocity of boat, this bike, is with respect to ground. So both are moving with respect to a common reference, that is ground, right? So we found the relative speed. Relative speed of car with respect to bike is vc minus vb. Here also we are doing the same thing. Here also we are doing the same thing. What is here? Here we have been given this vb is nothing but the relative speed. Relative speed. So basically this vb is nothing but velocity of boat with respect to river, right? So if that is the case, then we can write this as, so what will be the velocity of boat with respect to ground? That will be nothing but velocity of boat with respect to river minus, sorry, I write it this way. Now see, this velocity of boat, when I say, that is nothing but velocity of boat with respect to river. So if I have to find, and this velocity of d is nothing but velocity of boat with respect to ground, this thing. So now the things should be clear. I am writing this velocity of boat with respect to ground is nothing but velocity of boat with respect to river plus velocity of river. And that is also same here. I have written here. Here also I can rearrange this. I can say velocity of bike with respect to ground is equal to velocity of car with respect to ground plus velocity of car with respect to bike. So now you can see the similarity, right? Now you can see the similarity. So this is mathematically. And to understand this simply, I mean, why are we not adding here in case of rivers? Because you see, here this boat is moving with respect to water only. That is not a, I mean, another frame. This is, the boat is moving on water, whereas the car and bike are being seen from a third reference, which is the ground, right? So here also, if we see things from the reference of ground, we saw that now the equations are turning out to be equivalent. So there's nothing, I mean, when we say that effective speed of boat with respect to ground is equal to velocity of boat plus velocity of river, and this is nothing but the effective downstream velocity. So effectively we are using a relative motion concept only. This is nothing but a derivation of relative motion only, but we do not say in explicit thing, but we have seen this, right? There's an equivalence between the relative motion and the effective downstream motion of boat is nothing but the velocity of boat with respect to water plus velocity of water, right? So this was just the concept I just wanted to touch upon. We will see a few problems based upon this later on when we look into the illustrations. So now straight away we will go to the illustration. We will start with some basic questions and then we will increase the difficulty level. Now question 1 says a boat covers a distance of 15 kilometer in 3 hours when rowing downstream, right? On which draw figures. So that the river is flowing this direction, and 5 hours when rowing upstream. Now see, so here what is the distance being covered? Distance covered is 15 kilometer, right? 15 kilometer, right, downstream. And what is the time taken? Time taken is 3 hours. So what would be the downstream velocity? Velocity downstream will be nothing but distance upon time, 15 by 3, which is 5 kilometer per hour, right? Then upstream we know distance is again same. A boat is going, say suppose from point A to point B and then coming back, right? So D again remains same. But while in upstream the time taken is 5 hours. So what is the velocity upstream? That is 15 upon 5, which is 3 kilometer per hour. So now we have got the effective velocity, and when we say that this is with respect to ground. Now, so now we are, I mean, these things should be quite implicit. I should not mention every time. So this is the effective velocity downstream. This is the effective velocity upstream. So question is, what is the speed of boat in still water, right? So I have been asked velocity of boat, and velocity of boat. Uh, so this further I can write as velocity of boat plus velocity of river, and this I can write as velocity of boat minus velocity of river. So from these two I can say velocity of boat is nothing but velocity of uh, boat upstream plus velocity of boat downstream upon 2, right? This we had seen. So basically this will be 5 plus 3 upon 2, which is 4 kilometer per hour, right? So this is the answer to this question. Now the next problem says that a boat started from point A and rows downstream for 2 hours and then reverses and rows upstream for 2 hours. At this point, he finds that he is at a distance of 1 kilometer from A. What is the speed of the stream? Right. So let us see what happens. I mean, I draw the figure here. So suppose river is flowing in this direction at with a speed of VR. A boat starts from point A and rows downstream for 2 kilometers. Let this be 2 kilometer, reaches point B, and then reverses. Sorry, this is for 2 hours. And now from B, it reverses the direction and again travels for 2 hours, right? Say reaches some point here, C. Now certainly since the boat is in the second case traveling upstream, so upstream is a lower velocity, so in the same time it will cover the lesser distance, right? So that is why it is shorter from A, and this distance is nothing but 1 kilometer, but 1 kilometer. So this is a question given to us. Now we have to find the velocity of river, velocity of stream. So how to solve? So let us see. Let us assume that let's velocity of boat in still water be velocity of B, VV. So downstream velocity will be VV plus VR, and this is the effective downstream velocity, and at this speed the boat traveled for 2 hours. So this is the distance traveled, right? And the same distance, sorry, so this is the distance AB, and what is the distance BC? During BC, when traveling BC, the effective speed upstream will be VB minus VR, and this also the boat traveled for 2 hours, and this is the distance BC, and we know that AB minus BC is equal to 1 kilometer. So from here we can say AB is 2 VB plus VR minus 2 VB minus VR, and this is 1 kilometer. If we solve this, VB will get cancelled out, so it becomes 4 VR is equal to 1 kilometer. So from here, velocity of river is 1 by 4 kilometer per hour, which is 0.25 kilometer per hour. This is the very, I mean, simple solution, right? Now another problem, that is the rowing speed of a man in still water is 6 kilometer per hour in a river flowing at 1 kilometer per hour. It takes the same boatman 72 minutes to row a certain distance and come back. Find the distance, right? Find the distance. So let us see. So basically, this is a problem of average speed. This I should have taken later, but since it has come here, let us solve this one. Or maybe when I discuss the average speed, then I'll come back to this problem. 2b. Okay, we leave this at this point here. Now, question number 3 here. A steamer traveling upstream from Varanasi to Allahabad in river Ganga takes 5 hours to reach Allahabad, while the same steamer, while traveling downstream in return journey, takes 4 hours to reach Varanasi. Find the speed of flow in river Ganga. So let us see. A steamer traveling upstream from Varanasi to, so this is the river Ganga flowing. So suppose here is point Varanasi, on ground here is Varanasi, and here is Allahabad. Sorry, so if this is the velocity of river, if this way the Ganga is flowing, so this will be Allahabad and this will be Varanasi, right? Upstream is from Varanasi to Allahabad, so downstream will be Allahabad to Varanasi. And it takes the steamer 5 hours to reach Allahabad from Varanasi. So in the first case, steamer is moving this direction from Varanasi to Allahabad in 5 hours, right? So that is here you can say it is moving in this direction in 5 hours. While the same steamer, while traveling downstream in return journey, takes 4 hours. So now from Allahabad in downstream to reach to Varanasi, it takes 4 hours. Find the speed of flow in river Ganga. Find the speed of flow in river Ganga. So let us see here. So here actually we'll modify this problem. Otherwise, if we have to find the speed of flow in river Ganga, that we may not find. Data is insufficient. Actually, the question was find the time taken by boat to reach Allahabad from Varanasi in still water, right? In still water. That is first. And second, time taken by a hat, suppose, dropped at Allahabad to reach Varanasi. So there are two part of problem. This will be an important one. Conceptual also we'll see at various concepts here. Now see, there are two parts. So we'll first try to understand the question. Question says that the upstream movement of a boat in the river Ganga takes 5 hours, whereas the downstream movement takes 4 hours, right? So now see one thing. What is that effective when we say downstream, the effective downstream velocity is Vb plus Vr. Then velocity of boat in still water in Vb, and then velocity of boat in upstream is Vb minus VR. So now can we see this is a AP series, arithmetic progression with a common difference of VR. VR. So in VU we add VR, we will get the velocity of boat in still water, and in VB if we add VR, we will get the VB plus VR, which is velocity of downstream. So this is a AP series. So now, as we had seen earlier also, when speeds are in AP, the time will be in time will be in. So that is when speed. This is an important concept. When speed is in AP, time will be in HP. Right. So time was say suppose TD. This is set TB and this is set TU. Right. TD has been given as time downstream is 4 hours, time upstream is 5 hours. This TB, what will be TB? So this is nothing but TB, which is the time in still water, time taken by boat to cover the distance between Allahabad and Varanasi in still water, is mean of harmonic mean of 4 and 5, and harmonic mean of 4 and 5 is what? 2 into 4, 2ab upon a plus b. So 2 into 4 into 5 plus upon 4 plus 5. I mean, those of you who know this good enough, otherwise this we'll see in uh, sequence and series when we look into those concepts. But here we can know that harmonic mean is nothing but 2ab upon a plus b. Harmonic mean of a and b will be 2ab upon a plus b. So here it becomes 40 upon 9. So this is 40 upon 9 hours, right? So this is what this means, that time taken by boat to cover the distance in still water is 40 upon 9, right, hours. So this is the first part we have solved. Now for second part, what is it? Now see, I write here. So basically the distance, let the distance be d, right? Allahabad to Varanasi, let the distance be d. So that d distance in the first case, in the downstream case, at a speed of Vb plus Vr is being covered in 4 hours, and the same d distance during upstream at a speed of Vb minus Vr is being covered into 5 hours. So the distances are same in both the cases, so we can equate the two. So here we get that 4Vb plus 4Vr, it is 5Vb minus 5Vr. So it becomes 9Vr is equal to Vb. So basically we can say that Vr is equal to Vb upon 9. That is velocity of river is equal to velocity of boat in still water upon 9. And now we know the time, right? So can we say that time taken by river to reach Allahabad to Varanasi will, now the distance is same, right? Distance covered is same, Allahabad Varanasi. So when the distance is same, time and velocity are inversely related. So when VR is VB by 9, so we can say TR will be equal nothing but 9 TB, just the reverse, right? And TB we know is 40 by 9. So TR we can find as 40 by 9 into 9, which is 40 hours, right? This is the answer. So this TR is nothing but the time taken by the flow of water to reach a patch of a flow of water to reach from Allahabad to Varanasi. And when a hat is dropped, means hat does not have a speed of its own. So hat will travel with a speed of what? The river. And river is taking a time of 40 hours to reach from Allahabad to Varanasi. So it means that hat here in this part 2 will take 40 hours to reach from Allahabad to Varanasi. So it was an important concept that we use the funda of AM, AP and HP. So from here we could find that since the speeds, effective speeds or the speed with respect to ground is in AP series, so therefore time taken will be the HP series. So and HP series we knew that time taken in downstream is 4 hours, time taken in upstream is 5 hours. So time taken in still water would be TB, that is harmonic mean of 4 and 5, which is 40 by 9 hours. So this was an important problem. And now once we have found TB, we had to find the TR, that is the time taken by the river to reach, river only, right? River to reach from Allahabad to Varanasi. How to get that? So for that we had to find a relation between the velocity of river and velocity of boat in still water. That relation we found. Now since velocity and time are inversely related when the distance is constant, so that relation we used and we got the answer as 40 hours. Now we'll move to next question, which is question number 4. It says that 2 points A and B are located 48 kilometers apart on river front. A motor boat must go from A to B and return to A as soon as possible. The river flows at 6 km per hour. What must be the least speed of the motor boat in still water for the trip from A to B and back again to be completed in not more than 6 hours? Right. So this is a now case of average speed that we have seen. Actually, we have seen a full session on average speed, but here we just look in the perspective of boats and rivers. So see here, we'll first try to draw pictorially. There is a point A and point B which are located 48 kilometers. Distance is 48 kilometer. This is on a river front. So a river, I mean, this is a flowing. So a motor boat, so suppose a motor boat is here, which is going from A to B, and then from B to A it is returning also, right? The river flows at a 6 kilometer per hour. So the velocity of river, let this be in this direction at 6 kilometer per hour. What must be the least speed of motor boat in still water? That is VB we have to find, so that the whole journey, that is AB and BA both back, is completed maximum in 6 hours, right? Maximum in 6 hours. So total distance to be covered, distance is AB plus BA, which is nothing but 96 kilometer, and time permitted is 6 hours. So can we say what is the distance and time is given? So average speed will be VA, that is average speed. VA is distance upon time. So 96 by 6 is 16 kilometer per hour. So this average speed is given. Now further, let us see. We know that what is the velocity downstream, that is VB plus VR, which is VB plus 6, and velocity upstream is VB minus 6. This we know. So what is the average speed? Now, I mean, question is, here it is going by the speed of VD, and here it is coming by a speed of VU, right? So every in both the cases, I mean, while in the first case going from A to B and while coming back from B to A, distance being covered is same. So average speed in that case, average speed VA, that we know is nothing but 2 into VU into VD upon VU plus BD. This we had seen. So this will be 2 into VB plus 6 into VB minus 6 upon VB plus 6 plus VB minus 6, which will be 2 VB, right? A plus B we are doing. So 2 gets cancelled out. And this is nothing but essentially same as 16. This is also average speed. This is also average speed. So this is 16 kilometer per hour. So this we will solve here. So here it becomes VB square minus 36 is equal to 16 VB. So this we can rearrange as VB square minus 16 VB minus 36 is equal to 0. So we can factorize this. This will be 18 and 2. So VB minus 18 and VB minus 2 is equal to 0. So sorry, VB plus 2. So it will be VB is equal to 18 is a valid solution, minus 2 is not a valid solution. So that means 18 kilometer per hour should be the speed of the boat in still water, so that it can cover up and downstream both in 6 hours, wherein the velocity of river is 6 kilometer per hour. So essentially the concept of average speed we have used here, which is average speed is 2 VU VD upon VU plus VD, right? Now, having seen this, now we will go back to that problem which we had left here, and then we will see how to solve this question. So here the question is, the rowing speed of a man in still water is given, that is VB is given as 6 kilometer per hour, and the river is flowing at 1 kilometer per hour. So VR is 1 kilometer per hour. It takes the same boatman 72 minutes to row a certain distance and come back. So that means from point A to B and then from point B to A, it takes the same time. Sorry, I mean same distance, it takes total of 72 minutes. So find the distance. So this is D, let this be D also, point A, B, B and A. While D will be covered at a speed of what? 6 plus, I mean let this be the speed of river in this direction. So this is a downstream, so 6 plus 1, and here it will be 6 minus 1, right? So what is the effect average speed? So first I will find out what will be the velocity of downstream, which is 7 kilometer per hour, and velocity upstream is 5 kilometer per hour. So from these two, I can say velocity, average velocity for both up and downstream is 2 into 5 into 7 upon 5 plus 7, which is 12. So this becomes 35 by 6 kilometer per hour. That is VA, right? So VA is 35 by 6 kilometer per hour. Now at this VA, average speed, the boat is traveling for 72 minutes and covers a distance of what? So total distance, now I write total distance covered is what? AB plus BA. So this will be 2D, and time taken is 72 minutes. So average speed will be what? So that means 2D upon 72, this is in minutes, so multiply by 60 to get into hours. This will be 35 by 6, right? So from here we can get D is equal to nothing but 35 by 6 into 72 by 60. So this becomes 7 kilometer per hour, and this is the answer to this question. So this was essentially a easy problem based upon the concept of average speed which we used here, that is 2 AV upon A plus B, right? So now we'll move to question number 5. It says that on the banks of river Ganges there are two bathing points in Varanasi and Patna. So a diya left in the river at Varanasi reaches Patna in 24 hours. However, a motor boat covers the whole way to and fro in exactly 10 hours. Find the time necessary for the motor boat to sail from Varanasi to Patna. So let us see the problem here. Let this be Varanasi young point, and let this be the point Patna. Ganga is flowing in this direction from Varanasi to Patna. So on the banks of, and how do we know Ganga is flowing in this direction? Because on the bank of river Ganga there are two bathing points, Varanasi and Patna. A diya left in the river at Varanasi reaches Patna. It means that now since diya does not have a speed of its own, and Diya reaches from Varanasi to Patna. It means the river is flowing from Varanasi to Patna, right? In 24 hours. So Diya from Varanasi to Patna in 24 hours. What is the speed? Speed will be nothing but the velocity of the river. At this speed, Diya reached here. Whereas a motor boat covers the whole way to and fro in exactly 10 hours. So suppose now a motor boat will start from here, go to Patna and come back. Now it goes here at a speed of what? This is downstream, so velocity downstream, and it comes back at a velocity upstream, VU. Effective speed is VU, and in total it takes time 10 hours. In total it takes time 10 hours. So now see, how can we solve this question? So now see, first we know that velocity of Diya is nothing but velocity of river, right? And so distance, and let the distance be D, right? D. So D distance is covered by Diya at a speed of velocity VR in 24 hours. So this is one relation. So from here we can say velocity of uh, river is nothing but D upon 24. Now for motor boat we will see. Motor boat covers a total distance of 2D, right? 2D it covers in 10 hours at a speed which is Vd plus Vu. So Vd we can write as Vb plus Vr, and Vu we can write as Vu we can write as Vb minus Vr. So what will be the average speed of motor boat? This we are seeing a case of motor boat. So average speed will be what? 2 Vb, 2 into Vb into Vu upon Vd plus Vu, which will be 2 into Vv square minus Vr square upon 2 Vb. Vr will get cancelled out. So this is the average speed, and at this average speed, I mean, motor boat is covering a total distance of what? Here also D and back also D. Total distance is 2D at a speed Vv square minus Vr square upon Vb in 10 hours, right? Now here we will substitute D. Here we will substitute D. So D we can write as 24 Vr, right? 24 Vr. So here D I will write as 24 Vr. So 2 into 24 Vr means 48 Vr is equal to, and this Vb will be this side, Vr into Vb is nothing but 10 Vb square minus Vr square. So this will go 24 times, this will go 5 times. So this basically becomes 5 Vb square minus 24 Vb into Vr minus 5 Vb square is equal to 0. Right? This is a quadratic equation. So now we will solve this. So this will be what? This will becomes this will become Vb will be common. So Vb plus sorry, it will be minus here. Trying to write directly, Vb minus 5 Vr into 5 Vb plus Vr is equal to 0. So this negative solution will not take. So positive solution will be Vb is equal to 5 times Vr, right? So this we know. this is we have derived. Now we have to find the time necessary for the motor boat to sail from Varanasi to Patna. That is from this time we have to find. What is the time here? So time for motor boat to cover Varanasi Patna will be distance d at a speed of Vd, right? And d is nothing but we know d is 24 Vr, so it will be 24 Vr upon Vd is nothing but Vb plus Vr, right? I divide both numerator denominator by Vr, so it will be 24 upon Vb by Vr plus 1, which is essentially 24 upon Vb by Vr we have got as 5. So 24 by 5 plus 1, which is nothing but 4 hours. 4 hours. This is the answer. So essentially, I mean, this was equation driven approach, uh, but the concepts, I mean, the basic concept of what is the effective upstream velocity and effective downstream velocity. So that we need to be careful, and then we used a concept of average speed, and then after solving the quadratic equation, we got the answer to this question. Right. So now moving to next question, question number 6. Here it says a motorboat went downstream for 28 kilometer and immediately returned. It took the boat twice as long to make the return trip. If the speed of the river flow were twice as high, the trip downstream and back would have taken 672 minutes. Find the speed of the boat in still water. So what is the case one? A motorboat went downstream. So that means it goes from point A to point B, which is 28 kilometer. This is downstream. So this will be at a speed of Vd, and immediately turned back from B to A. It came back. So this will be at a speed of Vb and again 28 kilometer. It took the boat twice the time. Twice the time. So here it is taking 2t. Here it was taking t, right? So now see, time is twice. So we can say that speed would, I mean, distance they are covering the same. If in the second to cover the same distance, the boat is taking twice the time. It means that speed would be what, half of the first case. So here we can say that Vd is nothing but 2 times V. This is not Vb, this is Vu. This is also Vu, right? That's inversely proportional. Time, when distance is constant, time and speed are inversely proportional. So from this relation we can find that Vd is equal to 2 Vu from first case. Now if the speed of the river flow were twice as high, so let the river flow is flowing at a speed of Vr. So now it is saying that if the speed, so again same, from point A to point B, it is now it will be Vd dash. Vd dash, why not same as Vd? Because the velocity of river has changed now. Now it is 2 Vr, right? And coming back from B to A, the total would have taken at 672 minutes, right? 672 minutes to cover the total distance. To cover the total distance. Now let us see. So again we'll come back to the first case here. Now here Vd is equal to 2 Vu. Okay. So I can just suppose this Vu upstream, let it be V. Then Vd will be 2V. Then what will be Vb? That is the speed of the boat in still water. That will be what? Average of the two, right? Vd plus Vu by 2. So that will be 3V by 2. So from here, can we say that velocity of, and this is nothing but what? This will be Vb plus Vr. This is, sorry, this is Vb minus Vr. This is Vb plus Vr. And so now from here we can say that Vr will be nothing but V by 2, right? Because Vb 3V by 2 plus Vr should be V by 2, so that we get total 2V, right? So from these three equations we can get that velocity of river initially is V by 2. So now it becomes 2Vr. So 2Vr in second case becomes V. So velocity of river becomes 2, right? Velocity of river becomes 2. So what is the new velocity, effective velocity downstream? That will be what? That will be Vb plus Vr dash, which is, and Vb remains the same. I mean the velocity of both remains the same. So that will be 3V by 2 from here, plus Vr dash is now, that is the new velocity of river is 2Vr, which is V. So this becomes 5V by 2, and V upstream, the new in the second case, becomes Vb minus Vr dash. So that is 3V by 2 minus V, which is V by 2. So here can we say this, that now see, to cover the same distance, the ratio of Vd dash and Vu dash, Vd dash is equal is to Vu dash is what? 5V by 2 upon V by 2, that is 5 is to 1. So since the distance in the second case is being covered in the same, right, AB and then BA, so we can say that T downstream dash is to T upstream dash is nothing but 1 is to 5. So that means that in the second case the boat is taking, if 1 unit to reach from A to B, it will take 5 units to reach from B to A, right? So this is here TD dash and this is here TU dash, right? And the total is 672, right? Total is 672. So from now it will be TD dash will be what? 1 upon 6 into 672, which is 112 minute, and TU dash will be 5 upon 6 into 672, which is 560 minute, right? So 5 total 670 has been broken into 2, time downstream plus time upstream. So question is, find the speed of the boat in still water and the speed of the river flow. Right, to find the speed of the boat in the still water. So time, now see again. So here we know that time downstream is 112 minute and distance is same 28 kilometer. So 28 kilometer at a speed downstream is 5v by 2. So that is 5v by 2. So that is 112 minute, and by 60 that is hours. So right, this is the equation we can form here. So this becomes 28 to the 56 into 2. So basically we can say that v is equal to nothing but 6 kilometer per hour. So we have assumed here 6 kilometer per hour. So find the speed of the boat in still water, which is Vb. So Vb is equal to what? 3V by 2, right? 3V by 2. So 3 by 2 into 6, which is 9 kilometer per hour. And the speed of river flow speed in the initial case Vr is V by 2, which is 3 kilometer. Vr is 3 kilometer per hour. This is the answer to the both questions. So just to summarize here, here two cases were given. From the first case, since the upstream movement was taking twice the time being taken in the downstream. So from here we could deduce that the velocity downstream would be twice the velocity upstream, because time, if distance is constant, time is inversely proportional to the velocity, right? And further we could also reduce that if Vd is twice Vu, so if say Vd is 2v, then Vu will be v. From here we can find that Vb will be nothing but 3v by 2. And if these three are given, then we can find the velocity of river also, that as v by 2. The second case, now the velocity of river has increased from v by 2 to v, right? So now we can find the effective new effective downstream and upstream velocity, that we found out to be in a ratio of 5 is to 1. So therefore the total time taken for the downstream and upstream in the new case would be 1 is to 5, and total time was given as 672. From there we found the individual downstream and upstream time, and then further with some basic equations we could get to the answer, right? Now moving to question number 7. Question 7 says that Mohan and Karthik started off from Karamchat and Karamnasha respectively in their individual steamers along courses of river Durgavati at 10 meter per second and 15 meter per second respectively towards each other. Distance between Karamchat and Karamnasha is 60 km. After crossing each other at Pusali, which is 36 km from Karamchat, Mohan and Karthik reach Karmanasha and Karamchat respectively. After reaching their respective destination, they reverse their direction to come back to their respective starting points. Find what after what time they meet for the second time. So let us first try to understand the problem pictorially. There are two points on the bank of river Durgavati. So let this be a river Durgavati. This is point Karamchat. Let this be given by KT, and this point is Karmanasha, right? And a river is flowing from in this direction, right? Let this be the velocity of river. Now at this point, what happened? Mohan starts from Karamchat towards Karmnasha, and Karthik starts from Karmnasha towards Karamchat, right? So and they both have a different speed. So this here it is a speed of say 10 meter per second in water. I mean this is a speed of 10 meter per second, that is in water, and here Karthik is traveling at a speed of 15 meter per second, that is in water, right? Towards each other. Distance between Karamchat and Karamnasha is 60 km per hour. So this effective distance between the 2 points has been given as 60 km. After crossing each other at Pusali, which is 36 km from Karamchat. So now what happens? So they started from here. Here they meet. Uh, this let this point be Pusali P, which is 36 km from here. So it means it is 24 km from Karmnasha. Mohan and Karthik reach the other ends. That is, Mohan reach Karmnasha and Karthik reach Karamchat. After reaching their respective destination, they reverse their direction to come back to the respective starting points. Find after what time they meet for the second time. So here, now let us see. So let us try to comprehend the problem. First of all, how did we know that river is flowing in this direction? It's not mentioned anywhere. But see, thing is ki, what happened in the same time, effective distance covered by Mohan is 36 km, whereas effective distance covered by Karthik is 24 km. That is with respect to ground. So can we not say, I mean, speed of Mohan with respect to water is lesser than Karthik, but despite being lesser, Mohan has covered larger distance on the ground. How come? And certainly Mohan would have been aided by the speed of water also. So that is why we can conclude that river is flowing in this direction. I mean, mathematically also we can get this. Now see, if the distance covered is in ratio 4 is 36 is to 24, time being same, so the effective velocity, that is velocity of Mohan upon velocity of Karthik, and this is effective velocity, right? will be what? The ratio of the distances, which is 36 upon 24, and effective velocity of Mohan, that is a downstream velocity, because Mohan is moving downstream, will be 10 plus x, and Karthik is moving upstream, which is 15 minus x, and this is nothing but 3 is to 2. From here we will get x is equal to 5, right? 5 kilometer per hour, where x is nothing but velocity of river, that is 5 kilometer per hour. This is the one part which we have arrived at. Now see what happens when we in the meet. So what is the velocity of Mohan? That is 10 plus x, which is 15 kilometer per hour, and velocity of Karthik is nothing but 15 minus 5 is 10 kilometer per hour, right? So they will meet after time of meeting will be what? To cover a total distance of 60, and relative speed is, they're moving in opposite direction, so it will be 15 plus 25, right? So this will be nothing but, I mean here this 25 means speed of Mohan with respect to Karthik, right? So this becomes 2.4 hour, 2.4 hour. So now see, so they met at 2.4 hour. Now after, when Mohan reaches here at this point, then Mohan will move towards K. So to reach K, Mohan will take what? To cover 24 at a speed of 15, right? Or I mean, in overall, we can say that, I mean, uh, time taken by Mohan to cover the whole distance D will be what? 60 upon speed is 15 kilometer per hour, which is 4 hour. And time taken by Karthik to cover a distance D will be 60 upon 10, which is 6 hours. So basically, at the end of fourth hour, Mohan will be at this point, and that time Karthik would be somewhere here. So let me draw this again. So at the end of fourth hour, let this be Karmnasha and let this be Karmchat. So at the end of fourth hour, Mohan is here, right? He has reached from here to here, whereas Karthik is somewhere here, right? At a speed of 10, in 4 hours, he will be at a distance of 40 kilometers from here. 40 kilometers. This is 60 kilometers. So distance between these two will be 40 kilometers, right? Now, at the end of 6 hours, at the end of 6 hours, at end of 6 hours, what will happen? In 6 hours, Mohan will cover, Karthik will cover 60 kilometer. So Karthik will reach the point Karamchat from Karnasa. So here is Karthik, and by 6 hours, Mohan would have covered 15, 6 and 90. So that means from here to here 60, and then another 30, right? So here would be Mohan and here is Karthik. So basically this is 30 kilometer, right? In 4 hours, Mohan in 4 hour will reach here Karmnasha. Then another 2 hour he will reach the midpoint, which is 30 kilometer. So now what is the time when they meet for the second time? So the remaining distance is nothing but 30 kilometer, and they are now moving in opposite direction. So time taken to meet for the second time Tm dash will be 30 upon what? Relative speed will be again 15 plus 20, 10, which is 25 hours. So this is 25 hours after 6 after 6 hours, right? So basically Tm dash will be 6 plus 30 by 25, which means 7 whole 1 by 5, right? So basically 7.2 hours. So first time they had met for at the end of 2.4 hours. Now they are meeting at 7.2 hours. So the delta time, delta, the difference between the two becomes 7.2 minus 2.4. So that becomes after 4.8 hours. After 4.8 hours they meet for the second time. So question was easier only. I mean, just we had to see at which point of time which person is where, and then uh, we had to find the time of their meeting, right? Now moving to question number 8. Here it says that on the bank of river Ganga, Varanasi lies in between Allahabad and Patna, such that it is equidistant from both Allahabad and Patna. A steamer can go from Allahabad to Varanasi and back in 9 hours, while it goes from Allahabad to Patna in 8 hours. How long would it take to go from Patna to Allahabad? So easier problem only. See, it says that here is a point Allahabad, in midpoint is Varanasi, and then here is Patna. Now a steamer can go from Allahabad to Varanasi and back. So that means from here and then here, total time taken is 9 hours. While it goes from Allahabad to Patna. Now in the second case, from Allahabad to Patna and from Patna to Allahabad in, no, so it's given while it goes from Allahabad to Patna, that is in this motion. So this is given as 8 hours. So how long would it take to go from Patna to Allahabad? This time we have to find. Now see, on basic concept, if half of the, if this distance be d and another this distance be another d, so to cover a round trip d to go from Allahabad to Varanasi and come from Varanasi to Allahabad, that is 2d, total distance 2d. So total distance 2d is covered in 9 hours. So total distance of 4d, that is round trip from Allahabad to Patna and Patna to Allahabad. So 2d plus 2d, 4d. 4d will be covered in, so basically 2d, because average speed remains the same, no? I mean, average speed remains the same. So 2d it covers in 9 hours. So 4d will be covered in 18 hours, right? So now this 4d is for what? That is for Allahabad Patna plus Patna Allahabad. And Allahabad Patna has been given as 8 hours. So Patna Allahabad would be what? 10 hours, 18 minus 10, 18 hours. So how long would it take to go from Patna to Allahabad? That is nothing but 10 hours. Very easy. I mean, nothing else we have to do. Otherwise, we can assume equations also, but that will be, I mean, not very suitable, useless to do that. Simply, we have to, since Allahabad and Varanasi, so Varanasi is midpoint. So Allahabad to Varanasi and Varanasi to Allahabad is taking 9 hours, which is half of the distance if we compare from Allahabad to Patna and Patna to Allahabad combined. So half distance taking 9 hours, full distance will take 18 hours. Of the full distance, the downstream took 8 hours. So upstream will took what? 18 minus 8. 18 minus 8, which is 10 hours. Right. So this way we can solve this very easily. Now moving to question number 9. Here two boats are at the same point in a stream with speed of current being 3 km per hour. One boat starts traveling upstream at a speed of 8 km per hour, and at the same time the another boat starts traveling downstream at a speed of 6 km per hour. Both of them travel apart for 5 hours and then reverse their direction and are now traveling towards each other. From now onwards, in what time will the boats meet? So here the problem is, two boats are starting from the same point. One is going upstream, another is going downstream. Suppose let this be the direction of river we are. So upstream is moving at a 8 km per hour, and downstream is going at a 6 km per hour. So what will be the velocity upstream? That will be 8 minus, and VR is given as 3 km per hour. So it will be 8 minus 3, which will be 5 km per hour, and effective downstream will be what? 6 plus 3, which is 9 km per hour, right? So both of them travel for 5 hours. So from here, the distance, suppose it this covers VD into 5, and from here the second boat covers in a upstream, that is VU into 5. So this will be what? VU into 5 means 25, from here 25, and from here it will be 5 into 9, which is 45. So total distance will be 25 plus 45, which is 70 kilometer per hour. Now both of them, after traveling for 5 hours, reverses their direction, right? So when they are 70 kilometer apart, now they reverses the direction. So the speed of now the second boat, now the speed of say B1 will be what? Now it will be moving in downstream. So that becomes 8 plus 3, which is 11. And the speed of boat 2, which was earlier moving in downstream, will now move in upstream, which will be 6 minus 3, which is 3 km per hour. So, but again, both the boats will be moving in opposite direction, and they have to cover a distance of 70 km to meet. So in what time will they meet from this reversion point? So they will meet 70 upon 11 plus 3, which is 14, which is again 5 hours. So a interesting thing here. Okay, we'll come to this after solving part B here. Now let us see, let us move to part B. From now onwards, in what time when the boats meet, if the stream also reverses its direction at the same time, the boatman reverses their direction. So this, up till this point it is fine. Now what happens? Suppose here is second boat, first boat, and here is second boat, right? B1 and B2. Now at this point, B1 will reverse the direction and move towards this, and B2 will reverse the direction and move towards this direction. But earlier the river was flowing in this direction. However, the river also changed the direction, and now river starts flowing in this direction. So what will be the speed of VB1 now? Effective speed of boat B1, that will be what? In still water the speed is 8 km, and it is against the stream, so it will be 5. So it will remain 5 as earlier, and VB2, that is second boat, here it is 6. So now with 6, the add this VR will also be added. So it will be 6 plus 3, which is 9. So effectively they will cover a distance of 70 in what? They will cover a distance of 70 in 5 plus 9, which is again 5 hours, right? So irrespective of which direction the uh, flow of the river is, and flow of the river is the only thing which defines or which derives the effective speed with respect to ground of the any moving object, which is boat here. So irrespective of any whichever direction the river is flowing, we are getting the same time, which is 5 hours. And this 5 hour is also same as the earlier time of 5 hour, right? I mean, initially they moved apart for 5 hours, then it took them to meet again it 5 hours. Now it is irrespective of whether which direction the flow is there. So why is it so? Let us try to understand this in detail here. So basically what happens, this is river, right? Right. So here there are two boats, right? So one is moving at a speed of say 8 km per hour, another is moving speed of 6 km per hour. They move in their respective direction for 5 hours. So say suppose boat 1 reaches here, boat 2 reaches here. Now what happens? I mean, if we see with respect to water, don't see with respect to ground now. So with respect to water, the speeds 8 and 6 are with respect to water only, right? So since they have moved apart for 5 km, sorry, for 5 hours, so to meet they'll further take 5 hours, right? I mean, if we see with respect to ground, two objects have moved apart such that in 5 hours, so to meet also they will take 5 hours. So if we look in the frame of water, right, then it is much easier to conceive that since they have moved apart for 5 km, it is irrespective of which direction, what is their effective speed with respect to ground. I mean, since now we are looking in frame of water only, so it means that since they have been separated by a distance which is equal to say d in 5 hours, so to cover up that distance again they will take 5 hours. Or in another word I can say that they covered this distance which is 70 km in opposite directions in 5 hours, so they will again cover this towards each other in 5 hours only, right? So this is the beauty of this relative motion concept when we see in the frame of the water itself, right? So the time remains the same. So and this we can see also, right? I mean, generally also if we see that it becomes vb plus vx, vb1 plus vx, and another would be vb2 minus vx. Now if they are moving towards each other, vx will get cancelled out, so effectively it depends upon vb1 plus vb2 only, right? The which is the speed of the respective boats in water, right? So therefore, I mean, when we encounter such sort of problems, we should always think in terms of the frame in which the motion is happening, and here it is happening in water. So with respect to water, since they have been separated by 70 km in 5 hours, so to cover up that 70 km again they will take 5 hours, simple. Same case in part B also. I mean, irrespective of, I mean, since now we are looking in the frame of water, so it means that now we are in water, so I mean speed of water is immaterial, because when we look in the frame of say ground, though ground is also moving with respect to say sun at a certain speed, but that we do not factor in, right? If suppose person A and person B are moving at a speed of 5 and 7 km, we say that the speed of the second person is 2 km per hour with respect to person B, right? Because both are in the same frame of earth, whereas earth may be moving, but since in the frames are same, we need not consider the speed of the frame. And here in this case the speed of the water is irrelevant, or speed of water, the direction of the movement of water, both are irrelevant. What is relevant is the what is the speed of the respective moving objects in the frame of water, right? So therefore the answers were same here. So this concept we will make use of going forward. Now let us see that a ship of length 750 meter is moving upstream in the river and crosses the boat floating freely on the stream in 50 seconds. If the speed of the stream is 10 meter per second, what is the speed of the ship in still water? So let us see what will it be. So suppose this is water here. This is water. A ship of length 750 meters. So this length is 750 meter. Is moving upstream. So that means it is moving, say suppose this way, whereas river is flowing in this direction at a speed of Vr, which is given as 10 meter per second. Boat is flowing in this direction and it crosses, sorry, this is ship, and it crosses a boat. So boat is very small of negligible length, so that length we will ignore here. floating freely on stream. So freely means it will move with the flow of the stream, which is in this direction, right? So here velocity of boat is nothing but velocity of river. Now question is, what is the speed of ship in still water? So we have to find velocity of ship. So now we will again, we have either two ways. First we will try to find the velocity of ship with respect to ground. So that will be what? Velocity of ship plus velocity of, sorry, minus velocity of river. This is in opposite direction. So this will be Vs minus 10, right? And velocity of boat is velocity of river, which is 10 meter per second. So now there are two, and this boat is nothing but boat with respect to ground only, because anyway, uh, boat is not moving, right? And this river speed is nothing but river with respect to ground, right? Because we are seeing the speed of velocity from ground. So what is the distance? So now when will the ship completely overtake the boat? So to do that, this we have seen in rotary motion, the distance to be covered is 750 meters, right? 750 meters, and time taken is 50 seconds. So that will be what? D upon relative velocity of ship with respect to boat is equal to 50. This is given. Now what is velocity of ship with respect to velocity of boat? This is nothing but velocity of ship with respect to ground minus velocity of boat with respect to ground, right? And since here both are moving in opposite direction, so ship is a Vs minus 10 and boat is 10, but this will be minus of minus 10 because this is in opposite direction. So this becomes Vs, right? So from here we can say that Vs minus 10 minus of minus 10 is Vs. So velocity of ship with respect to boat, that is the relative velocity, that becomes what? That becomes d upon Vs is equal to 50, and d is nothing but 750 meter. So we can find Vs is equal to 750 upon 50, which is 15 meter per second, right? 15 meter per second. Mm. So basically I just, so this is nothing but Vsg here, velocity of ship with respect to ground. So velocity of ship with respect to ground is 15 meter. So we can find Vs from here. So in this equation we will put 15 is equal to Vs minus 10. So from here we get Vs is equal to 25. That is the velocity of steam in still water is 25 meter per second. Right, 25 meter per second. So now after having seen this, no, here this is velocity of ship with respect to boat. So that will be nothing but Vsg minus Vbg. So this already we Vsg from here we have written as Vs minus 10, right? Minus of 10. So this also. So which is nothing but 15 meter per second. 15 meter per second is the answer. Now this we saw in the frame of ground. In frame of ground. Now it will be much easier if we see in the frame of water. in the frame of water itself, or the so what happens now? There are two things. In frame of water, ship is moving at a speed of vs, and boat is moving at a speed of vr, right? So simply there are two objects moving. One is now see, so there is a ship which is moving at vs, and then a boat is here which is moving in this direction at vr. The distance to be covered is 750 meter. So the time taken would be 750 upon velocity of, now two objects are moving in opposite directions, so it will be vs plus vr, right? So 750 upon 750 upon vs minus vr. And now see one important concept. This is in frame of river, frame of river. So now frame of river, if we see the frame of, in frame of river, the river is not flowing, so the boat is also not flowing here. So basically what I will do, I just write it again here, that when we see in frame of water, in frame of water the boat will be constant. So velocity of boat will be constant in frame of river, right? This we can say. Here vv was flowing at a speed of river in the ground frame, but if we see in the frame of liquid, the water is not flowing, right? That is, so that in the frame of liquid even the boat would be stationary, so that is at a 0 kilometer per hour, and this will be moving at a vs. So basically this will become nothing but 750 upon vs. So 750 upon vs is given as 50 second, which is, from here we can say vs is 750 by 50, which is 15 meter per second. So this is much easier to think. Now again I just repeat this point. What I'm trying to say, in the frame of water, what happens in the frame of water, even if water is moving, we assume the water to be stationary. So with respect to water, the speed of ship is given as vs, right? So to cross the boat, the ship needs to cover 750 meter at a relative speed of vs, right? And that becomes 750 upon vs, which is same as 50. So from here we can easily get 15 meter per second. Now question number 11. A swimmer jumps from a bridge over a canal and swims 1 kilometer upstream. So let us see. Uh, let this be a canal. A swimmer jumps here at this point and then swims 1 kilometer. From here to here, he swims from A to B, which is 1 kilometer, which is upstream. So means a river is flowing in this direction. At first, after the first kilometer, he passes a floating cock. So there is a cock here, which is moving in. Cock does not have a speed of its own, so it will move along with the speed of river, so in this direction. So with respect to ground, that also will be at a speed of vr, right? Now he continues swimming for half an hour further this past this. So from here he continues swimming for half an hour, and then turns back towards the cock and swims back to the beach. So what happens? Swimmer and the cock arrive at the beach at the same time. So here at this point B, both had crossed each other. Now, after having traveled for half an hour in this direction, say, let this be D, the swimmer turned back, and now both the cock and the swimmer reached here at the same time. So this we are all looking in the frame of ground. I mean, so what happens? Let us see. Now, if we see in the frame of water, in frame of water, at this time, at this junction B, there was no, I mean, they were at the same point. So what happens after this point? They both separated for half an hour, right? This distance BD, in frame of water we will see, in frame of water, swimmer separated by BD in half an hour. So in frame of water, to make up this, to cover this distance, which is BD, swimmer will take half an hour, right? Swimmer will take half an hour. So basically, now what, I mean, whenever we take anything as a frame, so here we are taking water as a frame. So we will assume that water is not flowing, right? So water is not flowing, so cock is here only. So basically, the swimmer goes from BD and then comes back to DC. So the time taken, and since water is not flowing, so here we flowing, moving at a speed which is VB, both ways. So since to go from B to D, he is taking half an hour. So to come from D to C, which is again B, he will again take half an hour only, right? So basically, from B again coming back to this point B or C, B to D again coming back to point B or C, it takes in total 1 hour, half plus half, which is 1 hour, right? Now this is the benefit of taking a, so now basically, so it means that from ground, if we see, in 1 hour the swimmer has gone from B to D and then again come to D to A in the ground frame. And in the same 1 hour, the cock has covered from C to A. So in 1 hour, cock has covered distance C to A, right? So this distance that be D, that is at a speed of VR, and time is 1 hour, right? And D is nothing but this C to A, which is nothing but 1 kilometer, right? This is given A to B or A to C is 1 kilometer. So from here we can say velocity of river is 1 upon 1, which is 1 kilometer per hour. 1 kilometer per hour. So this is a classic case of a relative motion in water. So basically, a very interesting thing that I just summarize this, what happens. So basically, if we see with respect to anything, so we have seen this in relative motion. Whenever we take anything as a frame of reference, we assume that that is not moving. So if that is not moving, with that respect, what is the speed of the other object, right? So here, if water is not moving, right? So with respect to water, the swimmer is swimming at certain relative speed. Let that be VB. So he covered the distance BD. Then again at the same distance VB, he will come back to point B. So since in the upward journey he is taking half an hour, in the downward journey also he will take half an hour. So basically from B to D and then again D to C in the frame of water, he is taking 1 hour. However, in the real from the ground frame, that will be basically he's going from B to D and again coming back to point A here, right? From B to this point D and then again coming back here. In ground frame, if I draw this, in ground frame he is going from B to this point and again then coming back to this point. So this is the distance he is covering in 1 hour, and in the 1 hour the cock is covering a distance from C to A in the ground frame. So that we equated, and that is 1 kilometer he covered at a distance, I mean, at a speed of VR into 1 hour. So 1/1 is the speed, right? So similar problem, a boat is moving in a stream. While going downstream, it crosses a wooden piece. After 1 hour, it reaches the port and starts traveling in the opposite direction. Now, after moving for 1 hour, it crosses the wooden piece again, which is 8 kilometers downstream of the place where it was encountered earlier. Find the velocity of the stream. So, same problem. Let us see. this is a stream, a boat is moving here. So suppose this is boat. So when going downstream, it crosses a downstream. So water is moving say at a speed vr in this direction. So let this point be a here, and on ground let the corresponding point be x. Suppose after 1 hour, it reaches the port and starts traveling. When going downstream, it crosses a wooden piece. So suppose here it crosses a wooden piece. So wooden piece is here, right? When going downstream, it crosses a wooden piece. After 1 hour, it reaches the port. So now wooden piece is also moving in this direction, right? Boat from here reaches a port. Let this be port be B here, and on ground this is the point P, which is port, the corresponding point here. And this distance, this time is 1 hour, right? 1 hour. Time remains same in either any of the frame. You see, in frames, what happen? The velocity may vary in another reference frame. The distance may change in another frame, but the time will remain the same, right? So this we had seen in relative motion concept. So now here what will happen? From A to B, he is taking 1 hour, and after reaching port, start traveling in opposite direction. Start traveling, so he turns back, and he now starts traveling towards this. Now from here, after moving for 1 hour again, 1 hour, it crosses that wooden piece again here. So here he meets the wooden piece, right? Which is 8 kilometer. So let this point be Z here, and the corresponding point here be C. So this distance is 8 kilometer, because whenever distance is mentioned downstream, I mean this is with respect to ground, right? Because from the ground we are seeing this is 8 kilometer far. So find the velocity of the stream. So basically what happens now, if we see at this junction where boat is overtaking the wooden dog, right? So if we now see in the frame of river, the boat covers. So when we are taking the river as a frame, we assume the river is not moving. So hence the wood will also not be moving. So in that frame, the boat initially covers for 1 hour and reaches point B here in the uh, river, right? And in 1 hour, and from B again it will come back to the wooden place, right? So see, so initial 1 hour, the boat got separated from wooden piece in 1 hour. So to cover that distance again, he will take 1 hour, right? So basically, in 2 hours, the boat in 2 hours the boat goes from A to B and then again come back to the this location. So basically, in 2 hours, 2 hours, boat meets the dog again, and in the same 2 hour, in the same 2 hour, dog has covered 8 kilometer, right? So what is the speed of then at a speed of VR? At a speed of VR, because VR into time is 8 kilometer and time is 2. So from here we can say 8 by 2, which is 4 kilometer per hour, is the speed of stream, right? So this is an easy problem. Just the comprehension we need to be very sure why and how we are using. Otherwise, this is just a 1 second problem, right? So basically, we will assume with respect to water, the boat goes 1 hour away. Then to cover that distance, again boat will have to come back for 1 hour. So in those 2 hours, the boat will meet, right? So basically, if this information was not given, after 1 hour it reaches the port and now after traveling, after moving for 1 hour, it crosses. If this information was not given, then also the problem would have been solved. This piece of information is redundant here, right? So with this, we can get the answer as 4 km per hour. Now 13th problem, it says, while rowing a boat upstream in river, I accidentally drop my hat in the river but do not realize it then. After further 10 minutes of rowing, I realize the loss of the hat and immediately turn back. I catch up with the hat at a distance of 100 meters downstream from the place I had dropped the hat. Find the speed of the current. So let us see here. Suppose this is the river moving in this direction at a speed VR. At this junction, I dropped my hat. So I am, that is boat. Boat is going in upstream, right? So boat is moving in upstream. So basically, what I do, I just, let's suppose this is the speed of river VR. So boat is moving. Boat is here at point A. It is moving in this direction. So here the hat is dropped. Hat is dropped, right? Let this corresponding point be here X. Now, but here when the hat is dropped, I do not get to know that the hat has been dropped. I keep on moving for 10 minutes. I reach the point say B. Let the corresponding point on the ground be say Y, right? Corresponding point on the ground be Y. Another, so this is a 10-minute journey upstream. Whereas as soon as this hat falls here, it will start moving with the speed of the flow at the speed of VR in this direction. Now, so after 10 minutes, when I realize, I turn back. So what happens? Again, the same problem. So now see, in the frame of water, if we assume the things in the frame of water, the hat will not move because the water is stagnant. So since I have moved away for 10 minutes, so to cover that distance to reach to H, I again need to travel for 10 minutes. So basically, boat will meet the hat in 10 plus 10, which is 20 minutes, right? And further piece of information is given, in the same 20 minute, the hat had covered 100 meter downstream from the place where I had dropped the hat. So that is, it's saying that hat had come from X to another point Z, which is 100 meter, right? So basically, I caught the hat here, right, which is 100 meter from this point. So this 100 meter with respect to the ground, the hat speed with respect to ground will be nothing but the speed of river into time, which is 20 minute. So 20 by 60, right, hours. This is also meter. So basically, what I do, this will be 20 into 60. So it becomes 100 upon 1200. So this becomes basically 5 meters per minute, the velocity of the river. So pretty simple. Now it looks like, if we start looking in the frame of the river, and that is the beauty of the relative motion, right? Otherwise, if we had to solve this in the frame of ground, taking the effective downstream and the upstream motion, it would have been really difficult and consumed a lot of time in solving the equations, right? So now we'll move to the next problem. Here it says that there are three ghats, Assi, Dasaswamedh, and Manikarnika on the river Ganges in Varanasi are located on the river bank. The speed of the river flow is 8 km per hour, and in the direction of its flow, Dasaswamedh Ghat being located midway between Assi and Manikarnika. So that means it is given that here 80 is there, midway is Dasaswamedh, and far end is Manikarnika. Now, two boats, Samrat and Vikrant, leaves Dasaswamedh at the same time. Samrat floating, and suppose Ganga is flowing in this direction, right? Suppose no, it's given because uh, it's given that the river flows at a speed of 8 km per hour in the direction of its flow, Dasaswamedh Ghat being in the midway between Assi and Manikarnika. So this VR is given as 8 km per hour. Now, when two boats, that is Samrat and Vikrant, Samrat floating freely down the river to Manikarnika. So from D, Samrat is flowing freely at a speed of VR, right? So basically the speed with respect to liquid is 0, with respect to river is 0 of Samrat. And whereas another boat is there, which is Vikrant, that is moving at a speed of, here it is given V upstream. Having reached a sea, so what happens? Now we track the movement of Vikrant. Vikrant starts here, reaches a sea, then again turns back and goes to Manikarnika. So having reached a sea, the boat Vikrant reverses its direction and starts to Manikarnika. Find the range of values of V for which Vikrant arrives at Manikarnika later than the boat Samrat. So, I mean, we have to find the value of V such that Vikrant reaches here after Samrat has reached from, I mean, freely floated from Dasaswamedh to Manikarnika. Right. So, this is the question here. Now, see, uh, Assi, Dasaswamedh, and Manikarnika all are the points on a ground, right? So this distance, let's suppose be D. So this will be also D, and this will be 2D. So basically, for if we see for Samrat is covering a distance of D at a speed which is VR, right? It will be floating freely with respect to ground. So that becomes D upon 8, and that is the time taken by Samrat. Whereas time taken by Vikrant. So Vikrant is first moving in this direction and then in this direction. So time SA, that is from, sorry, time DA, that is from Dasaswamedh to Assi, is nothing but D upon V minus VR, which is I write as V minus 8 directly, V minus 8, V minus 8. And now time for A to Assi to Manikarnika is total 2D distance upon. Now in this here, the speed will be what? That is in direction of water, so that becomes V plus 8. So this is V plus 8, right? So total time will be time from S, sorry, Rasaswamedh to Assi to Manikarnika will be D upon V minus 8 upon 2D upon V plus 8. And now it is given that this time should be time Dasaswamedh to Assi to Manikarnika should be less than time taken by Samrat, right? So that is D upon V minus 8 plus D up 2D upon V plus 8 should be less than D upon 8. So if we solve this, this will, I mean, D will get cancelled out. So it becomes V plus 8 plus 2V minus 16 upon V square minus 64 is less than D by, sorry, this will be 1 by 8. So this becomes here 3V minus 8 multiply by 8, so it becomes 24B minus 64 is less than V square minus 64. 64 gets cancelled. So basically here it becomes v into v minus 24 is greater than 0. Sorry, mistake here. It says that Vikrant takes a time longer. Vikrant should not reach earlier at Manikarnika than Samrat. So it means time taken by Samrat is lesser. So we just reverse the sign here, right? So this becomes that Vikrant takes more time to reach. So here it will be less than. So basically this will be nothing but 0, 24. So here we can say that v should be less than, from here it's coming 0 and 24. However, this v minus 8, right? So we can say speed cannot be negative. Effective speed cannot be negative. So then in that case v should be greater than 8. V should be greater than 8 from this condition. So v should be greater than 8. These two gives v should be between 8 and 24 is the required solution to this question. So I mean, moderate level question only. Only thing we had to just trace the movements and apply the required condition and then get the answer. Now moving to, I think this is the last problem for this session. So we have tried to cover all variety of questions on boats and river. This is the last one. So on a river there is no current from A to B but a current from B to C. A man rows down a stream from A to C in 3 hours and upstream from C to A in 3.5 hours. Had there been the same current in all the ways as from B to C, his journey downstream would have occupied 2.75 hours. Find the length of time his return journey would have taken under the same circumstances. This is a good question, difficult one. So let us see how to solve this. So it is like there are 2 points A, then there will be some point B, then there will be some point C. Now it is given that there's no flow between A to B, whereas there is a flow between B and C. Okay, a man rows down a stream from A to C. So it means that river is flowing this direction at a speed of say VR. So a man rows down a stream from A to C in 3 hours. So it means that the man is going from here to here, then again from here to here uh, in 3 hours. So suppose this time is t, so this time, I mean, so this will be 3 minus t, and this distance AB, he would have covered A, B, he would have covered at a speed which is VB, that is velocity of the boat in still water, and this he would have covered velocity in the downstream in 3.t times, right? Now had then and upstream, that is from C to A, so from C to B he would have come, and then from B to A he would have come, and this time has been given as 3.5 hours. So now see one thing. Now see, uh, if we compare here A to B and B to C, so this is a upstream movement. So this will be velocity is upstream, and time we do not know. We do not know as of now. Now this BA is what? This is neither upstream nor downstream. Here also, since this is no wave or no speed, so speed will be just the speed of the boat in the or the man in the still water, VB. And since AB here in the first case and here also AB, same distance, same speed, so time taken will be T. So if this is T, so here the time taken will be 3.5 minus T, right? 3.5 minus T. So this is the second part. Now the third is given, had there been the same current in on the wedge as from B to C, his journey downstream would have occupied 2.75 hours. So third scenario says, this is the first scenario, this is second scenario. Now third scenario says ki downstream, that is from A to C. Now there is a wave. So here he first goes to A to B and from B to C. So this means it is A here, it is B here, it is C here. So now this is a, now the motion of wave or motion of a stream is there right through from A to C. So this here we can, now it will be velocity downstream, right? And here also velocity downstream. Now see, from the first condition and the third condition, in the first condition the distance BC is being covered at a speed of VD, so time taken is 3 minus T. So here also it will be same time, same distance, same speed, so same time for BC part 3 minus T, and total time is 2.75 hours. So out of 2.75, 3 minus T has been taken in BC part. So what will be the time taken in AB part? That will be 2.75 minus 3 plus T, which is nothing but T minus 0.25. That is the time taken. So now the problem is find the length of this return journey under the same circumstance, that is when the river is flow of the river has a speed right from A to C. So fourth condition is that from here C, a river, a boat starts upstream, that is upstream, and then again from reaches B, and from B it reaches A upstream. So here velocity upstream. Now see, when velocity is upstream from 2 in part case 2 from C to B, same distance at a same speed of VU, and here also same CV distance and VU speed. So time will be again 3.5 minus T, right? But here do we have anything for the part AB? AB is the distance. AB, do we have anything VU? No, we do not have any common speed. So let this time be T dash, T dash. Now one more concept we will use here. Let us see. Now see, this is VB, VD, VU. So this is just the speed of the boat in still water. This is the speed of the boat in downstream. This is the speed of the boat in upstream. So this is in AP, that is VU, VB and VD is in AP. So the time taken would be in HP, that we can use, right? I mean even if we don't use, then we'll have to take the proportionality and then solve. Then also we can do, but since we know this concept, we will make use of this. So since VU for part AB, VU, VB and VD are in AP. So we can say that T dash T minus 0.25 and T will be in HP. So from here we can say that T minus 0.25 is nothing but 2 into T dash upon T plus T dash, right? This we can use. So from here we can, it will be T into T minus 0.25 plus T dash into T minus 0.25, that is equal to 2, and this also will bring this side minus 2 into T dash into T is equal to 0. So T dash we will take common, so it becomes T minus 0.25 minus 2t, right, plus t into t minus 0.25 is 0. So from here we can find the value of t dash is nothing but t into t minus 0.25 upon, this becomes here t minus half, this will be t minus zero point 0.5, right. There has been some mistake here, I just basically, so see here for vv the time is t and for vd the time is t minus 0.25. Earlier it was reverse. So from here we can say that t is equal to 2 into t dash into t minus 0.25 upon t dash plus t minus 0.25. So if we solve this, we will get this as t t dash plus t into t minus 0.25 minus 2t dash into t minus 0.25 is equal to 0. So from here I can take t dash as common. So it will be t dash, if I take common 2t minus 0.5 minus t as common, it will be equal to t into t minus 0.25. So that if I substitute, I get this as a relation, right. So this is the relation which I have got, that is the t dash this time is nothing but t into t minus 0.25 upon t minus 0.5. Otherwise also we could have got this. How come? Because we could have equated the ratio of vv and vd, right, taking the proportionality. Now after having done this, we have to find the length of the time his return journey would have taken. So this t dash now we know, and this 3.5 minus t we know. So after this, one more condition we will use, that now see what happens here. I write here only that now see third and the fourth case, the speed is vd, time is t minus 0.25. Here speed is vu, time is t dash. Here speed is vd, 3 minus t. So both the cases, I mean ab distance, here ab distance. So since the distance is same, since the distance is same, so the ratio of so in this case, can we say in the case of, we can say that vd by vu, distance is same, so that is ratio of speed will be inversely proportional to the ratio of time. So it will be t dash upon t minus 0.25. And in this case, again bc and bc same, so I can say the ratio of speed will be the inverse of the time. So it is 3.5 minus t upon 3 minus t. And since both the ratio are same as vd upon vu, so we can equate these two relations. So this I equate here. So that is t dash minus, so basically that is t dash upon t minus 0.5 is equal to 3.5 minus t upon 3 minus t. 3.5 minus t upon 3 minus t. And then t dash value I will substitute. T dash I had got at t into t minus 0.25 upon that. So this I will substitute t into t minus 0.25 upon t minus half 0.5 and into this t minus 0.25. This will get cancelled out and this is equal to 3.5 minus t upon 3 minus t. If we solve this, this becomes 3t minus t square is equal to, here it becomes 3.5t minus t square minus 3.5 into half plus t into half. So here minus t square cancels out. So basically what remains, this 3.5t plus t by 2 4t. So 4t minus 3t is equal to t and this side it will be 3.5 by 2 which is 1.75 hours. So the value of t we have got as 1.75 hours. So find the length of the time his return journey would have taken. So basically his return journey takes what? T dash and 3.5 minus t. So return journey takes t dash plus 3.5 minus t. T dash value we can substitute here, that is nothing but t dash we can find as t, that is 1.75 into 1.75 minus 0.25 upon 1.75 my 0.50. So this value will be, this we will calculate. Let us see what does it come. So 1.75 into 1.5 divided by 1.25. This we get as 2.1 hours. 2.1 hours. Right. And the second part, 3.5 minus t. So 3.5 minus 1.75 is 1.75. And here it is 2.1. So these two, if we add, this we get as 3.85 hours. So total return journey is 3.85 hours. That is the answer to this question. So this was lengthy also, and this was a bit conceptual also. So the concepts which we used, let us again revisit those. Basically, it is given that in the first case, the AB part, there is no speed of the river, but in BC part, there is a speed of the river. So that is downstream VD into 3 minus T. Now in the upstream, the boat will come from C to B at a speed VU, and from B to A, again no stream, so it will be VB. So since the AB and AB both upstream, downstream, there's no motion in the speed remains same VB. Effective speed is VB in both cases. So time will be T. So if this is T, it will be 3.5 minus T. Now in the third case, when the stream has a speed right from A to C, so in that case, going downstream at a speed VD for the journey AB and for BC again at VD. So now from first and the third scenario, we can say that in the first scenario, the BC distance was covered at a speed of VD in 3.3 minus T. So here also BC distance at a speed VD will be covered at 3 minus T. So what remains here is 2.75 minus 3 plus T, which is T minus 0.5, 0.25. Now in the fourth case, which is upstream, so from C to B, VU. So BC we know from the second case, VU, that is upstream, covered in 3.5 minus T. So this will be 3.5 minus T. However, for BA we did not know what will be the time. So that we assumed as T dash. So T dash we preferred using, taking the help of what we call the AP-HP relationship. Otherwise we could have gone with the proportionality also to get that, but that I mean this is much more simpler AP using APHP. So since VU, VB and VD are in AP, so time corresponding times, that is T dash T and T minus 0.25 will be in HP. So it means that T will be nothing but 2 AB upon A plus B. From there I got a relation for T dash. And now this is the first part. Now the second relation, because when I compare 3 and 4, from 3 and 4, AB part and AB part, both the distance is same. So the distance is same, this ratio of speed will be the inverse ratio of time. So Vd by Vu will be T dash upon T minus 0.25. Similarly for BC part, Vd by Vu will be 3.5 minus T upon 3 minus T. So, and since these two ratios are same, Vd by Vu and Vd by Vu, we will equate these two in the next part, and from here we will solve the value of T. T we get as 1.75 hours, and T we had assumed that this is the time taken to cover the AB part at a speed when there's, I mean, speed of the boat in a still water, when there's no flow, right? So that is 1.75 hours. So from there now we could, then we found the value of T dash, which is 2.1 hours, and then that we added to find the total return journey in the fourth case, in case 4, and that is 3.85 hours. This is a good problem. I mean, various concepts we used and then got to this answer. So this is where we end this session. Hope this was useful to you. Any query you can write to us, or you can post in the comment box, that we'll try to answer promptly. Thanks for watching this.